A network attached storage device on NAS is a great way to be able to store your data or share that data amongst other computers on your network. But of late, they're actually getting turned into more of a centralized computer, really, used for streaming videos as well, running virtual machines and so on. And there are quite a lot of good vendor solutions out there. The only trouble is, you've got limited options, really. There's not a great deal you can do in terms of improving the hardware, for example. The software that they provide is actually proprietary, so it might be a case of you may not even be able to disable certain services, let alone uninstall them. So that's got me thinking about more of open source solutions. And I've been using one like FreeNAS for a long time now, although it's now under the umbrella name of TrueNAS. One of the benefits of that is you can actually buy an actual pre-built NAS that's, the whole hardware and software solution in one, or you can actually build your own computer, download the software, install it, and then configure it as you see fit. So, how do you actually install this TrueNAS? Well, if that's something you're interested in, stick around and watch this video, because that's what we'll be doing. Now, I will include a timeline in the video if you prefer to jump to a particular section. But since we're actually going to be building our own network attached storage device, we do actually have to download the software first. So that's why I'm on the TrueNAS website here. Now you'll notice it references TrueNAS as well as FreeNAS, and that's just because there used to be two different versions of this software. But now it doesn't matter whether you're going for a pre-built NAS that's got the software already installed, or whether you're building your own, it's just going to be called TrueNAS. So the first thing we need to do is to click on that download button there. And that takes you to, well, it's a case of they want to know if you want to actually join up to their newsletter. You don't necessarily have to, entirely up to you. In our case, I'm just going to click on the no thank you link there, and that takes us to our download page. So I'll just scroll up a bit here, and we've got a button here saying download now. So we can just click on that button and it'll download an ISO file. The only thing is, well, most computers these days can't actually boot from an ISO file or a CD drive to be specific. So it's a case of we do need the software to actually convert that ISO file to create a boot disk, a USB drive to be specific. So we need this Balena etcher as well. So it's a case of just go straight to this URL. I'll include both links in the description. Click on the download button there, and you'll then be able to download this actual software that'll allow you to burn that ISO image to a bootable USB drive, and then you can actually boot your computer off that USB drive and start actually installing the software. Now, unlike Rufus, for example, which is just a standalone application, you actually have to install Balena Etcher onto your computer. So the file that you download is actually a setup program. So when you run that, you've got to go through an installation process to install the software onto your computer. But once it's installed, it's just a case of probably double clicking an icon on the desktop, and then you launch the application itself. Now, it doesn't know what ISO image we want to use, so we've actually got to tell it, and we can do that, for example, by clicking on this option here, which is Flash from File. We then select the actual ISO file we want to burn to our USB drive. So we've got choices with Windows. You can either just select the file, click on Open, or you can double click it. It makes no difference. We've now told it what ISO file we want to use, and the next step is, well, where do we actually want to burn this to? So if you hover over here, for example, it's telling me it's going to be using my USB device that's in drive F. It's a case of I actually only have one USB drive plugged into the computer anyway, so it doesn't matter. But if you want to pick another one, you would click on the change button down there. Do be very careful if you've got multiple devices in here, because once we click on this flash button, which is the next step, it's going to wipe any data that you've got on that USB device. So do make sure that you're using the right one. Ideally just remove all other ones and only use that one you want to wipe. That's the safest way to do it. But it's pretty straightforward now. It's just a case of click on the flash button. Now it is going to launch a command process in the background, so I'm getting this warning about user access control. Basically, it's a case of the actual application wants to launch another application. Are you sure you want to do this? So in my case I do, so I'm just going to click on yes, and then off it goes. It actually starts to create a bootable drive on that USB drive using that ISO image. So I've got to wait a while because it's going to actually flash the drive, then it'll go through a verification process. But then once it's finished, we'll have an actual USB drive to boot from. Now, as you can see, we're actually logged into an ESXi server. And that's because I'm going to be installing TrueNAS onto a virtual machine rather than a physical one. I mean, at the end of the day, the actual installation process is going to be the same. It just means that this virtual machine is going to be booting off an ISO file, whereas a physical computer will boot off a USB drive. But either way, it'll still load the same software into memory, and they'll still go through the exact same installation process. Now, I've effectively just kind of like cobbled this together, really. I mean, take these sort of like figures and numbers with a pinch of salt, really, because it's a virtual machine, so I can just come up with anything I like, really. The reality is I don't really need that much in terms of CPU performance. I don't really need that much memory, hard drive capacity. I can just make it up on the fly. I can change it and do whatever I like because it's a virtual machine. But obviously when it comes to the physical world, you'll be buying, hard drives that have probably got much more capacity than that. For example, you'll probably have a computer that's got way more physical processors than that. You might find actually buying two 16 gig sticks of memory, well, actually it's not that much more expensive to buy two that have got two 32s to give you 64. It really comes down to your budget and so on. But part of the reason for actually building this virtual machine is, well, for one thing, it makes recording the video easier because I've got access to this through a browser and I can just get straight access to the console. So yeah, that's one particular reason I'm doing it. Another reason is because if I've got a physical NAS and a virtual NAS, I can actually take snapshots on this virtual machine, and then what I can do is I can test a patch on this. So if an update comes out, I'll test it on the virtual machine. Assuming it doesn't break, I can then apply the patch to the physical machine. If I don't have this, on the other hand, it's a case of I could end up breaking my NAS, and that means rebuilding it. So this makes my life a lot easier down the line. Another reason for doing it is that I'm going to have virtual hypervisors on this actual lab that I'm running. And it's a case of, these are nested hypervisors, they're running within this actual ESXi server. And I want to be able to test out things like data storage, for example, sharing data between hypervisors, because I've got two hypervisors, two real physical hypervisors, I should say. And again, I want to be able to do my testing on that. I want to test out patches, for example, test out new features, and I want to do that virtually first before I run the risk of trashing the real ones. So yeah, there's some good advantages really of having, virtualized systems. But anyway, like I say, I mean, take all this with a pinch of salt. I mean, there are different sort of like strategies in terms of the builds you want. It might be a case of maybe you can't fit this many hard drives into the case, maybe you can fit more. What I've done is I've set it up so it's got a reasonable amount of processing power. It's got probably way more memory than it actually needs, but it can actually, TrueNAS and ZFS, that can actually take advantage of some more memory. I've actually set it up so that it's got two hard drives here, and I've deliberately set them up with slightly a lower amount of capacity than the rest, because these are going to be the actual boot drives, and I've got two of them because I want redundancy for the operating system. So the idea is I want to install TrueNAS onto these two drives and they'll be mirrored. So the idea is if an actual hard drive fails, I can then basically replace that. The computer will still run. I've just got to go and source another hard drive. I'll replace that and I'll get it to basically fix TrueNAS, and then we're back to having our redundancy again. So yeah, we've got two drives. They'll probably end up being SSD drives. I'm not going to go with things like a USB drive. It is possible, but it's not advised. But the strategy would be they'll probably just be a couple of low-level SSD drives because we don't need that much capacity. Now these drives, on the other hand, these are actually going to be used for the data pool. So for these in the real world, these would actually be, for me anyway, they'd be mechanical drives. I'd go with genuine actual NAS drives more than anything. I mean, you can actually get mechanical drives, you can get SSD drives, you can get NVMe drives. Just bear in mind that NVMe and SSD is based on flash. They don't have the same capacity when it comes to the number of writes that they can tolerate. So it's a case of you're really better off with mechanical drives. They will be slower than the SSDs and the NVMEs, but they'll last a lot longer. So it's something I'm more inclined to do, is to probably build a computer that's got probably a lot less memory than that. I mean, the minimum is just 8 gig. Although, as I say, you can, if you can afford 32 gig, 64 gig, whatever, by all means take advantage of it, especially if you're going to be putting virtual machines in. Probably put a couple of SSDs in there, and they're pretty easy to fit in. I might even go with NVMe's. It really just depends on how cheap they are these days in comparison. And then these ones, they'll all be mechanical drives. So as long as the actual case has got the capacity to store 5 drives, that's probably good enough for me. There are going to be other options, as I'll explain in the video, but for this particular lab, that's basically enough for me. I mean, the reality is this is all getting stored on a single NVMe drive. This is all completely virtualized. I'm just fooling the operating system into thinking there are more drives, but it allows me to actually test out, things like the data pooling and so on. So that's something to bear in mind anyway. Now, another thing I've done is I've given these 2 separate network cards. So the idea is this one's connected to my infrastructure network. This is where I'm going to be managing it from. The expectation is in the real world, that's probably like just a 1 gig network card. That one on the other hand is going to be my storage network interface. So that one probably will be plugged into an actual 10 gig network interface port. So the idea is then I've got much higher throughput on that storage interface as opposed to this one. So one of the reasons for having 2 network cards as well is that if I've got a storage network, there's always the potential, especially in business, where you can actually overwhelm a network card potentially if there's too many computers trying to send data to it or pull too much data down from it. So I always want to have 1 card left behind as the management card that's pretty much free to use all the time. Less chance of it, getting overwhelmed, in which case I should always have management access to the computer, and then I can do something potentially to reduce the load on the interface, for example. So pretty straightforward in terms of the setup. The only thing I'll point out when it comes to the virtual machine is that I've set this up based on FreeBSD 12, also based on a 64-bit operating system. So yeah, pretty simple setup as far as a virtual machine goes, but the reality is you'll really want to be doing something like this on a physical computer. So next thing to do is really get this thing booted up, get it to load its operating system from the actual ISO file, and then we'll actually start the installation process. So once it actually boots up, it doesn't actually take too long to get into the boot menu. I'll just widen this out to make it a bit easier to see. Just going with the defaults there, so just automatically boots up, although it does give you other options. So basically it'll just load itself up into the actual memory, and then we've got a series of choices as to what we want to do. So just make sure I click the window there. So a few options, but by default it's to do an installation, so we'll go with that default. And then it wants to know, well, where do you actually want to install TrueNAS? Now in my case I want redundancy with my NAS, so all I've got to do is select the drives to tell it which drives to install the operating system itself on. But because I want the redundancy, I want to pick 2 of them. So I've got 2 20 gig virtual drives, if you will, and I want to use those to actually install the operating system on. So it'll create a mirror of these 2 drives, and the idea is if one of these drives were to break, the NAS will still carry on going. Now in a virtual machine that's kind of pointless, really. I mean, in the grand scheme of things, everything I've got's running on one actual computer, one actual hard drive anyway. So it's a case of this is all academic. But if this was a real NAS, that would be my strategy, is to have 2 physical hard drives to cover me against failure of an actual hard drive itself. And then if that drive breaks, I can replace it. So I've picked those 2. Not particularly much in terms of disk space, so I'll just go with them. Then it's going to warn me that it's going to actually wipe the data on those drives, which is fine. So one thing to point out though is that it does actually give you some notices down below about the type of drives to use. So for example, it's actually warning you do not use USB drives. I mean, I've had a similar sort of issue before in the past with like pfSense, for example, which uses FreeBSD, and that had a similar issue where that if you lose power, for example, it just completely trashed the actual drive, the USB drive. I've found it always has problems for some strange reason. I mean, USB drives aren't particularly useful when it comes to actually this sort of stuff, because they're not as, I would say they're not as good when it comes to all the writes that have to get done to a drive, especially if you're logging a lot of information to a drive, and that's usually what happens by default. All the logs that get created typically go to wherever you've installed the boot system. So it's a case of I found after a short time to stay away from USB drives and typically use something like SSD drives because they're pretty quick to boot from. I mean, you could go with NVMe, for example, as an alternative, but it's a case of that'll be more expensive than an SSD. And when it comes to the boot drives, you don't particularly need that much for the storage anyway. It's a bit quicker than the mechanical drives, I must admit. So it's kind of like a trade-off. That you can't get as many writes out of an actual SSD drive as you can out of a, say, like a mechanical drive, but it is at least quicker to boot. So I'm just going to go ahead because, as I say, it is warning me the fact that it's just going to wipe all data, but it doesn't really matter because we don't have anything on these anyway. So it's asking me for a password, and that's going to be for the root account because that's going to be the only account we have to begin with. So I'm just going to put a relatively easy password in there, but you really should be using a much stronger password than that. Now it's giving you a choice of whether you want to boot off of the different two methods. In my case, I prefer to stick to the BIOS options with FreeBSD, so I'm just going to go with that, which is the default one anyway. And then off it goes. So it's just going to go through this process of starting the installation, and then eventually it'll come back and start asking me questions. So I'm just going to pause it there, and then once we're ready, I'll bring you back. Now that part of the installation process is already completed, and it's telling me it's actually installed TrueNAS onto the two drives that we selected there. And it's now a case to actually reboot the computer and get it to load up the operating system to proceed. But it is giving you that warning to remove the installation media first, because otherwise you could end up in a loop, especially if the BIOS is set up to always boot off the USB drive in preference, for example. So if you've got a physical and actual computer, you would want to remove that USB drive first. In my case, it's a virtual machine that tends to prefer the actual hard drives anyway. So I'm just going to go with OK. Assuming I actually select the window first. And then that's it, really. Go for reboot the system. And then it'll reboot the system, and now it's a case of it'll actually load up off the actual hard drives, and then we'll actually go through the rest of the installation process. Well, the computer's actually now up and running, and it's a case of we're in the console. I mean, there's not a great deal you can do through this console because really you're going to be managing through a web browser, and that's why it's given us those URLs at the actual end. But interestingly enough, it didn't actually prompt me for any authentication details. So out of the box, the console is actually unsecure. One thing of real interest, I mean, aside from the fact you can reboot it, shut it down, you can actually get into the shell, for example. I'll just click back on that window and hit option 9. So I've got actual access to this through the shell account, and I didn't need to know the actual, password of the root user, but I've got rights of the root user. Likewise, if I don't know the root password, I can just change it. It doesn't actually prompt me for the existing password either, which is interesting. So I just need to put in a new password, put in the same password just to confirm that I know what I'm putting in. And that's it. I've changed the password of the root user account without actually knowing what the existing password is. So that's that's an interesting feature, shall we say. Something to bear in mind, that out of the box, the console is actually very unsecure. Anyhow, the real thing is, going forward, we need to manage this through the actual web interface. So we've got a choice of 4 URLs here. Now, the first two I'm going to completely ignore because they use HTTP. It's an insecure protocol, meaning if I actually logged into this computer using HTTP, using a web browser, anybody in the path between my computer and this NAS would be able to read the actual user account plus the password, because it'd be getting transmitted in clear text. So those first two are completely out of scope. We can't touch those at all, or at least we shouldn't. The last two, on the other hand, are what we want to be using because they use HTTPS. But as you'll notice, one's got an IP address, one doesn't, or other one's got an IP of 0000. That's because the way I've set this up is kind of similar to what you would do in a production environment. You have really 2 sort of interfaces at least. One's a storage interface, so that's where all the data transfers get done. So they'll typically be high capacity network cards, 10 gig, 40 gig, 100 gig, whatever capabilities you've got. And then we've got a separate network card, which is really used for management of the computer. So we keep them separate, so the management interface will have lower bandwidth. But it's a case of if that storage card would ever get overwhelmed, so for example, there just might be just too much data trying to be read from the computer or sent to the computer, you might struggle to get management access to it. So by having this separate interface, and I'll be using that for doing the patching, being able to do remote management and so on, chances are that should be relatively free 99 times out of 100. There won't be that much traffic on the interface. So it's a case of where we need to go next then is to log into this computer using a web browser. So I'm going to jump across to my management computer and we'll log into it from there. Well, as you can see, we're now on our management computer and I've connected to the NAS. So because I'm using HTTPS, it's making a complaint of the fact that it's not secure. And the reason for that is because the actual NAS is using a self-signed certificate. So I've had to accept that. And by doing that, it's now brought me to the actual login prompt. So that's a good thing. At least it's actually asking us to log in. So I'm going to put in the details and then we'll log in. Getting started. Okie dokie. Right, so just telling us about like where you can get documentation and so on. So it brings us to this dashboard, gives us details about CPU utilization, memory utilization, and all sorts. It's a bit difficult to see because it's a relatively small screen that we've got here. But one of the first things I do need to do is start making some changes to the actual networking, for example, because at the moment, well, the computer's actually getting its IP address through DHCP, so I need to change that. So I've come down to here where it says network, and then I'm going over to global configuration. So unlike some operating systems where you configure things like the default gateway, for example, on an interface, here you actually configure it as part of the global config, which kind of makes sense because for most computers there will only be a single default gateway, so it kind of makes sense to put that sort of information here. But anyway, one of the first things I want to do is change the domain because by default it's set to local. So I'm going to change this to templab.lan. Default gateway will be 172.16.17.254. So this is remembering things from a previous NAS that I set up. So that's more to do with the browser than the actual web server itself. So for the DNS servers, 172.16.17.10. No idea where it came up with this my admin, but yeah, whatever. So we've changed the domain name, changed the DNS server, changed the default gateway, and that's pretty much it as far as I'm concerned. I mean, there are other settings. I mean, we've got like a legacy version of NetBIOS and a slightly newer version. I mean, incidentally, a lot of these fields that you're seeing here, they've all got this little question mark against them, which is useful. So it's kind of like it's sort of like a mini help system, if you will. So if you click on a question mark, it's in, for example, this is a legacy NetBIOS naming service system that's used, goes more back to the original SMB version 1 there than anything else. Whereas if you go to WS Discovery, it's seeing that's more newer, if you will. So I don't need to change anything there. I'll leave that one there. That's to do with multicast DNS. I don't need to set up things like the proxy and so on. So that's all I need to touch. I mean, I'm not going to be using IPv6 yet. As ever, my own internet service provider still does not support it, even after all this time. So I'm just going to ignore it. If they're not going to use it, it's no use to me either. Right, click on save. Now, for me, this does take a bit of a while to save these changes. Bear in mind, this is a virtual machine, but we're also running with actual hard drives that are actually set up as thinly provisioned. So, yeah, for me, making changes like this, it can drag out a bit. Anyhow, we'll then go down to interfaces. So, for me, I've actually got two of them, and it's identifying them based on the names. That's how FreeBSD referenced them as being. So we've got this one up here, which is more to do with management. That one's more to do with the actual storage. So what I want to do is I want to get the management interface off of DHCP and onto a manual static IP. So we've got a little arrow there. If you click that, it expands all the information out. And then I can click on edit. So this takes us into the details of that network card and how it's set up. So you can see we're on VMX0. It's set up to use DHCP, so I'm going to disable that option. And now I need to put in an actual IP address. Now, this actually needs to be 17.30. So I'm going to change that to 172.16.17.30. I'm just double checking that it lines up with the existing subnet. Now I don't need to change the subnet mask, or what you see here is a prefix length. 24, that's the default, and that's fine by me. So I'm going to click on apply. Now, interestingly enough, it gives us an option to actually test these before it's actually going to be, permanent, if you will. So what I can do is I'm going to click on the option there, which is to test changes. And we're just going to confirm that and click test changes. So I'm going to then try to connect to 172.16.17.30. So you can see we've connected in. So I'll click on advanced. I'll accept that certificate. So I've now got to log in again. It would help if I put the correct password in. So now it's saying, all right, well, it looks as though these have worked. So I'm going to go with the option to save those changes because that's what we want. And then it's just reminding us, yes, these changes have been made permanent now. So I'll just close that. Now, if you go back to this original tab here, you can see that it gave us about 60 seconds before we would end up reverting them. We've got the option to revert it manually anyway. So by connecting over to the new IP address, it then gave us that option to actually save the changes. So that's it. That's how you basically change network IP addressing. And then lower down, there is another option for static routes. In a production environment where you've got multiple network interfaces, that can make sense. In our case, I don't really need that because with the two interfaces I've got, that's going to be connected to through a firewall, so hence why I need a default gateway. That's just going to be direct connectivity. So I could put a new IP address in there, but it's pretty much the same process. So other things you can do. Well, up here we've got an accounts option. So we can create groups, for example. We can create users. Now, when we first connect in, it's telling us that there's information in here that's hidden. So there are actually groups in here, and if you click on the little wheel up here, it gives us an option to actually show all of the hidden groups that are already been configured on here. So there's quite a lot of by the looks of it. So we'll click on the wheel again, and this time around it gives you the option to hide them. So that's quite useful if you don't necessarily know about certain groups or you're looking for certain ones. And I do quite like these filtering options. If you then go to users, you can see we've got a default root user, if you will, but again it's reminding us there's actually hidden ones in here, so we'll just close that. We go to our little wheel again, click on show. Yeah, there's quite a lot of users have already been created here, so I don't need to necessarily know about those, at least not now anyway, so I'm just going to hide them. So the idea is, I mean, this methodology has been around for quite some time, is that when it comes to sharing out folders or giving access to computers, it's better to create groups and assign permissions to the groups rather than to specific users. So the idea would be you would create a group and then you create your users and you join them to that group. You then assign permissions to, say, a specific directory or a specific share on the actual NAS to the group. So then anybody who's a member of that group has access to it. Because the idea is people come, people go, and it's a case of it's much easier by keeping those people all in specific groups. It's much simpler for manageability. Down here we've got an option for system, and there's a lot of things we can set up on here. Some of the options we've got, for example, if you go to general, so here for example we've got the web interface IP address. I mean, it comes with its own self-signed certificate, but you can actually change it if you want to. What concerns me is that specific IP address there. I want to pin the management of this computer to a specific interface. So the idea is I don't want somebody to be able to get management access to this through the actual storage network card. So if somebody somehow found a way into the actual storage VLAN, for example, I don't want them having even that option to get into the web interface on here. So I prefer to pin the actual management to a specific interface. So I've deselected that option there and I've pinned it to this specific IP address. So going forward, once I've saved these changes, it should only be listening for actual web connectivity through that specific interface. It's more secure because this interface is sitting behind a firewall. Now, it's also got options for access to the computer. By default, it's set up to accept access on port 80 for HTTP, port 443 for HTTPS. So it always makes sense to change these to something different. So it would be a case of I would normally pick a completely different number, like for HTTPS, for example, some other number that's not commonly used, so that if somebody gets onto the network, if they try to connect to this through port 443, well, they won't be able to get access to it if I change that to some completely random number, for example. So I like to do that on any computer operating system that's got a web management interface, change it to something else. Now, for the sake of this video, I'm just going to keep things simple. I'm going to leave it as is, but basically just put in a number, something else, for example, change that, and then going forward, you're going to have to change it. You're going to have to point it to a specific port, for example. Now, the web interface option here is where it's giving you the option to force connectivity from HTTP over to HTTPS. So if you click on the question mark, it tells you about that. Because the idea is you don't want anybody connecting on HTTP. So I'm quite keen to tick that box. Actually, I'm going to make this a bit easier. I'm going to keep it simple for now. So the idea is if somebody does try to connect to this on port 80, for example, will be forced over to the management port. It's kind of a dilemma in the sense that I don't want somebody getting access on that port to this one. So if somebody connects on port 80, they'll be redirected to 4444, which means they don't necessarily know what it is. So yeah, kind of a dilemma. So I need to put that onto something else as well. Otherwise, if somebody knows to connect on port 80, they'll learn what that port is anyway. TLS options are to do with the security level options for the encryption. So I'm going to actually deselect TLS 1.2 to make it a bit more modern and more secure. Time zone I want to change. So click the drop down on there. So I'm going to scroll through this lot and find something different. So for me, it's Europe/London. That's my region, basically. We've got other options on here, like your time zone, for example, or time format, I should say. I do prefer it left at that at a 24-hour, but you can swap it over to like AM and PM and that sort of stuff. The date format, by default, it's the year, then the month, then the day. For me, it would be slightly different, so I'll change that. Crash reporting, this is something that's information that's going to get sent, which, to be honest, I don't want these. I don't like vendors, I must admit, that set those by default. To me, this should be something that you opt into. I don't feel you should be opting out. This is something you should opt into. So just double checking to see if there's anything else I feel that we need. I mean, we've got an IPv6 address option up there, which I'm not really interested in. Leave the language, console, keyboard. So I'll click on save. So I've got to remember that I need to connect on port all the 4s basically. Right, so it's saying that because we've changed these, we now need to actually restart the web server. So we've got to confirm that, which is a good thing. So that way you don't accidentally restart things. I like how they always just double check, like, are you sure you want to do that? So we'll do that. Now, let's see if we can then reconnect to this. So this is going to be 17.30, but port 4444. So it might take a bit of a while for the actual service to restart. So I'll just pause it there and then I'll bring it back once it's ready. Well, we're now connected into the NAS on port 4444 using HTTPS. For me, it was a case of, well, I needed to update the firewall to allow access to that port. So that was a bit of a hindrance. But I mean, let's say, for example, I try to connect to 172.16.17.30. So that's just the HTTP port. I'll be very, very specific. So we've changed that, so we shouldn't be able to get access. Nothing should happen here. It should eventually time out. On the other hand, let's say we try to connect on port 800. Now in my case, it won't work because I'm not having access to it on the firewall. I mean, obviously that was the original challenge of that port, and it's a case of I'm not allowing access to port 800. So yeah, that's not going to work for me. But the idea is that if somebody does try to connect on HTTP, they'll be forced over to using HTTPS, which it makes sense because you don't want to be using unencrypted protocols. But anyhow, now that we're connected back in, I mean, there's various other things you can set up. I mean, you can change the NTP service, for example. It actually does come with some ones already preset. So if you do want to change these, then by all means do so. You can add new ones as well. So entirely up to you. I mean, you might want to be very, very strict in terms of only allowing access to an internal NTP server, which itself then goes out to NTP, because there's always the risk of somebody being able to mess around with the NTP out there, because if it's not getting authenticated, you don't necessarily know that what's coming back is genuine. So that's something you might be thinking about. Not really too concerned about the boot. Advanced, not really something I'm going to be getting into either. But this is for changing things like down here, for like changing your syslog settings. So in a business, you might want to be changing that sort of thing. The emails is useful in the sense that you might want to actually get authentication. Well, you might actually want to get actual notifications, I should say, through email. So if something happens, an alert gets sent out, you actually wanted it to be sent from a specific email address, which connects to maybe an internet server or even an internal server if you've got one. And then that sends an email to whoever it's going to go to. And then off you go. You've got a notification system going on, and you can set that all up within here. Other things we've got. I'm not going to touch the system data setting. Choices here about setting things up in percentages. These are just all various tweaks that you want to be playing around with more than anything. And then you've just got, this is all preset about, it sends emails with warning at warning level, SNMP traps, it's got to be a warning level, but you can change these if you want. Now the alert settings, I must admit, this is quite interesting. There's quite a lot of alerts that it'll act on. One of which you'll notice is even on things like certificates. That's especially important for businesses who've actually supplied actual certificates to computers, because I mean, normally like in a lab, for example, you're connecting using a self-signed certificate. It doesn't really expire. You're just accepting that it's a legitimate certificate. But the trouble is, you go out and purchase a certificate, it's going to expire within maybe a year, for example. So it's useful to get these certification warnings, for example, and that's what it's doing. It'll send out alerts, so you can play around with these, alter these, and that sort of stuff. But these are all the different alert settings. There's quite a lot in here. I'm not really going to touch cloud credentials here because I'm not using a cloud. It tells you about the SSH connections, key pairs, tunables. Aren't something you touch unless you're really familiar with something like an operating system. Updates, definitely useful. I mean, this is going to go off and check every day to see if there are any updates available. But I do quite like this in the sense that maybe you don't want to have the risk of your NAS having access to the internet, in which case it might be a case of you can actually download the file from another computer that does have access to the internet. Then you get it across to this computer and tell it to install it manually. So that's an option. Then we're into certificates down here, the certificate authorities. That's where you'll be changing things like the actual certificate that the actual device uses itself for management. We've got options for support, which this is an open source operating system, and I don't have a license for it. I can still use it, I'll still get the features, but I don't have an actual license available to get the the actual technical support, that sort of stuff. Two-factor authentication, it's giving you the options for. Only thing to bear in mind is that if you lose access to the internet, because that's what this is relying on basically. I mean, it's talking about things like Google Authenticator, for example. Two-factor authentication makes a lot of sense for a computer that's actually on the internet or is touching the internet, in other words, accessible from the internet. Because there are botnets, for example, out there. There are systems out there that are running 24/7 trying to hack into some computer. They'll just go to an IP address and they'll try to log into something, see if they can eventually try to brute force it, for example. By having two-factor authentication, you don't just need to know the user account and the password. You also need to be able to have access to that two-factor authentication system. The only drawback is if you're on a private network, if you don't have access to the internet at the time, this system can't go out and check to make sure that yes, you have entered the correct details, for example, or yes, Google says you're authenticated. So that's something to bear in mind, is that you're at risk here, that if your internet connection goes down, you won't be able to get back into something like this until your internet connection's back up. So it makes a lot of sense. It adds some really good security here by having two-factor authentication. You don't just have to have the user account and password, you have to be able to pass the two-factor authentication. So yeah, it's way more secure. So even if somebody puts a keylogger on your computer and steals that, for example, they still can't get in because they've got to go through this two-factor authentication. So something to think about anyway, if that's if you're really into the security aspects of it. Tasks, not too fussed. That's just a series of tasks currently going on. What is important when it comes to the installation, though, is the storage, because the actual NAS itself, all we've done is we've just installed the actual operating system. Now I've installed it onto 2 drives which have been mirrored, so it gives me some redundancy. What this thing doesn't have is actual data storage. We don't have actually any way to actually store data. Users can't upload data anywhere. It just doesn't exist. So we've got to come to this storage option here and then to pools, and we've actually got to tell it in this case to add a pool because, well, we don't have one. So you can import a pool. So if there's already an existing pool from somewhere and you've imported it into the system, you can import it onto the actual computer itself and get it to use that existing pool. But in our case, we've got to start from scratch. So we've got lots of options here. I mean, I've got quite a few drives to pick from, but the first thing I've got to do is create a pool. So I'm just going to go with what I've been using before. In this case, I'm just going to call it pool 1. Call it what you like, really. It's more specific to the computer. But what you've then got to do is you've got to actually tell it what disks you want to use. Now, you do have options here where you can, for example, click on the suggest layout. And what it's going to do is it's just going to sift through these drives that you've got, and it's going to try and work out what the best options are. Now, in my case, I've got all of these drives. They're all 100 gig. But if they're of different capacity, for example, that could be a problem, because all the drives have to have the same amount of capacity to be able to be pulled together. So, for example, if I've got, say, 2 or 3 that have only got 50 gig in capacity, then that's pretty much my limit. I can't get more than 50 gig on a drive, so I can't really pair it up with another drive which has got 100 gig and then get 150 gig out of the 2 of them, for example. It doesn't quite work like that. So you try to get drives that have all got the same capacity, and you just end up with the lowest denomination at the end of the day. But there's various options, and like I say, there's a sort of like an automated process where you just click that, and in my case it'll just select every single drive out of this available list here, and then it'll suggest I use that. So what I would end up with is 3 data drives here to give me close to 300 capacity between them, and then what it will do is it'll pick the other 2 as what are called parity drives. So what happens then is all the data actually gets spread around amongst the 3 actual drives here. So these are the actual data drives, and then it forms a kind of parity. It creates like a checksum, if you will, a computation on these other drives, so that if one of these drives fails, it can run an algorithm and it can work out from these parity drives what data is missing, and it can actually rebuild that onto a drive that we replace. So that's quite useful. But you've got lots of flexibility here. So for example, I could pick these 2 drives here, for example, here. Click on the arrow here. You can see this is now turned to a brighter shade of blue. So we pick our drives up here if we're doing it manually. Click the arrow and it adds them into this, what it calls a data VDEV. So by default, it's doing what it's calling mirroring. And you can see it's telling you that roughly you're going to get 98 gig out of this. So even though we've got 2 drives capable of 100 gig capacity each, what it's actually doing is it's creating a redundant pair. So it might be a case of this is the real drive and it's mirroring all the data onto this drive. So whenever data gets sent to this drive, it gets mirrored across to here. So that's why it's saying mirrored down there. So effectively, you actually have half of your capacity. But what it means is that if one of these 2 drives fails, it can still carry on. You would then replace that drive, recreate the mirror, and you're back to square one. So it's very good for data redundancy, and that's exactly what we did with our bootable disk. We took two drives and mirrored them together. The other option when you've got, say, two drives is you can do what's called a stripe. So this is, from what I recall, this is RAID 0, which is just a stripe. Here we've got 196 gig. What we're doing here is that we're actually sending the data, we're striping the data across two separate drives. And that's why we're getting close to 200 gig out of these. You'll never get the entire lot of capacity, but you look at that and it sounds, oh, that sounds a lot better. I'm getting 200 gig here. That sounds much better. The only trouble is if one of these disk breaks, it's game over. You've lost all of your data. So yeah, it's a bit of a trade-off there. I mean, the both of them are quite good in that when you've got two disks, you can actually read data from both disks at the same time. So it's faster for transferring data off the NAS. The trouble with mirroring, though, is it takes longer to write because it's got to write, it's got to write the data to a drive and it's got to mirror that to another drive. So it's a bit slower for the write speed. So you're getting the benefits of a read. So you get faster reads. You can pull data off the NAS quicker, but it takes longer to actually send data to the NAS. I mean, there are other options. We can pick another disk here, for example. Once we hit 3 of them, we actually get into what's called RAID Z, or RAID Z if you prefer. So you can see it's still 196 gig. So there's still effectively two drives being used, but it's a case of we've got what's called a parity drive, basically. So it's a case of two drives are our data, and it does computational work on that drive, so you can restore if one drive fails, like we're saying. If we add another drive to the pool here, we'll get into what's called, well, I don't want to create that. We now get what's called RAID Z2. So that's where we've now got two parity drives. So we've still only got the capacity of 200 gig, but we've got two drives. So this is quite useful in the sense that, say this drive here fails, we can still carry on because we've got this drive plus these two parity drives. On your hand, say one of the parity drives fails, technically it doesn't really matter because we've got a data up here anyway. But the idea is we can tolerate two drive failures from that, but they usually recommend you really want like 3 data drives anyway, at the very least. So this is what I was talking about right at the start. This is, if I'd clicked on that suggest layout option, this is what it would have gone for. So we would actually end up with 3 data drives, giving us almost 300 gig plus 2 parity drives. That's why it's RAID Z2. So it's creating a RAID set out of those 3 and then creating these extra 2 drives for our parity. The RAID version 2 versus 1, it's better to go with 2 if you can, in the sense that it's just that extra load. When you actually do experience a hard drive failure, although to be fair, I think in my years, decades of computing, I've only ever seen one hard drive actually fail that I've had to replace. Years down the line where I've taken a hard drive out of a cupboard that hasn't been used in a long time, yeah, it didn't work. But I've only experienced one that's failed personally. When it comes to businesses that do much bigger data reads and writes, yeah, it does get quite familiar, shall we say, where you've got to start replacing drives on a regular basis. And the trouble is, if you purchase all of your hard drives at the same time, so if you're doing a new build, bear in mind you're getting all of these hard drives out of the same batch. So you are at risk of more than one failure because they're all produced at the same time in the same batch process. So ideally, if you can, buy some of the drives from, say, one vendor, buy other drives, can be the same model or slightly different as long as it's got the same capacity. Buy them from a different vendor, so you reduce the risk of this from happening. Now, one thing I'll do, actually, I'll just take one of these drives out because I want to show you something different. I'll go over this in another video because one thing I'm not going to get into too much detail is setting up the actual storage itself in terms of shares, and that's all for another video. But other things you can do, I mean, once you've actually got your pool set up, you can actually start adding a disk in for another purpose. So it's not technically part of the pool, the data pool per se. And this comes through this option up here, which it says add vdev, and gives you all these different options. So for example, you can actually add a drive in as a hot spare. So the idea is that if a drive suddenly fails, there's a hot spare immediately available and TrueNAS can then take advantage of that to actually then start replacing the failed drive straight away. So instead of you having to actually go out and purchase a drive, having to wait for a new one to get delivered and so on, you can get TrueNAS to take advantage of a hot spare and start doing that for you. Then all you've got to do is actually replace the genuinely failed drive, and then that becomes a new hot spare. Another option you've got is you can add a drive in to part of that pool, if you will, which is a cache, if you will. So if you've got relatively slow drives, it's actually more common for SAN storage, where you've got these big drives and you use like SSDs for the caching, for the more commonly used data, if you will. And then you've got mechanical drives sitting at the back end there. They're really seriously sophisticated what they can do in terms of caching your data. In this particular case, for your small business and for your typical personal usage, that cache drive, chances are you won't really see much of a benefit. The idea is it's supposed to be there that you should be able to pull data off a cached drive at a much quicker rate than off the actual mechanical drives, but for your typical user you probably wouldn't see it, so it's not something I'm going to be bothering with myself. What I would be considering though is the log drive, because as it says, that's very beneficial when it comes to write caching. I'll go into that in another video because it's more to do with protocols like NFS, for example, because it's talking about synchronous writes. Rough overview, it's a case of, if you've got these mechanical drives, it's a case of the NAS is getting instructions to save data. It's going to save that data to the drives. Now, with something like NFS, which is a synchronous process, the actual computer that's sending the data is going to sit twiddling its thumbs effectively, waiting for the NAS to write that data to disk and confirm that the data has been written before the actual computer will send more data to the actual NAS, which makes NFS, for example, a very slow process compared to, say, like iSCSI, which is asynchronous. The problem is, there is a way to get around that, but one option you've got is to create what's called this log drive. So the idea is you've got a much quicker drive available. So for example, like an NVMe drive, for instance, the NAS can actually write to that single drive, or you'd really want to have two, to be honest. You'd want to set those up as a redundant pair in case you lose the power, for example. The NAS will write to that log drive at a much quicker rate, and then it'll be able to tell the actual computer, right, we've written the data. And then in the background, it then transfers all of that data off the log onto the real mechanical drives, because mechanical drives are much, much better. I mean, it might be tempting to go out and purchase a bunch of SSDs like this is referencing, but you really want mechanical drives, proper NAS capable drives, ones that have been set up specifically for a NAS. Even if you're a home user, you may as well go for the proper versions, because they're better suited to handling a long number of writes, or a lot of writes, I should say. SSDs won't last as long. They are very, very quick, but the trouble is they're not geared up to survive as many writes as, say, a mechanical drive, so they won't last as long. So it's more tempting to go with those mechanical drives, to be honest. But like I say, you can speed things up by adding, for example, that log drive as well. Anywho, thanks to the wonders of virtualization, I'm just going to add that drive in to my pool, because what I can do, I can just add in an extra drive to this at a later date, and then it's a case of voila, I've suddenly got an extra drive and I can start playing around with this. But what I want is, I want these 3 drives, or at least I'm fooling the system into thinking it's got 3 drives plus 2 parity drives. So that's what we're going for. Now, one thing I will mention, actually, up the top it talks about encryption. Now, personally, I wouldn't encrypt the actual pool drive. That's the actual pool of disks itself. I'd reserve that more for the individual folders or datasets, as TrueNAS references them. The reason being is not all of your data needs to be encrypted. And the problem is, if you encrypt something, you've got the problem of performance. You've got to encrypt data, you've got to decrypt the data, you're putting a lot more load on the computer, and it's slower to act. if you've got to pull data off the NAS, it's got to decrypt it off the hard drives first before it can give it to the computer that's requesting it. So it's going to take longer. So it does have a performance hit. But what I would say is you definitely still want to encrypt any private or personal data that you're storing on something like this. Part of the reason for that is if you've got any data on here and it can be used against you, for example, in the case of identity theft, for example. I mean, you might be a case of you're storing information about yourself when you're conversing with like the tax authorities, for example. That could be used for, if somebody gets their hands on that, that could have the potential for somebody to be creating bank accounts in your name. Next thing you know, it's a case of you've got all these loans taken out in your name and you have to pay them. So that sort of information, if you're storing it on a NAS, you do want to make sure you encrypt it, but I wouldn't necessarily encrypt the entire pool. Create these separate data sets or folders where you're going to store that sort of information and encrypt that. So it's, it might be data that you rarely access, for example. So in my case, for example, I mean, I'm creating a lot of YouTube videos and I keep the actual finished video. I upload it to YouTube, but I actually keep the raw video. So that's something I upload to the actual NAS. But that's not something I need to encrypt, and these are very big files. So it's not really in my interest. If somebody, got access to it, it's on the public internet anyway, so I wouldn't be concerned. On the other hand, if I've got personal information, the last thing I want is that getting out into the public domain, where somebody could then go out and start creating bank accounts, for example, in my name. So yeah, there is some sort of like data where I do have to keep it encrypted. And one of the reasons I do want it encrypted is the fact that in my my career, I have heard of cases where businesses, they have to abide by strict regulations in terms of data protection. And I've heard situations where somebody actually they've got some contract with a third party for destroying data. So for example, it might be a case of you've got to destroy the physical hard drives. You've actually got to destroy the non-volatile memory, volatile memory, whatever it is. You've actually got to get that destroyed mechanically. It's not, it's not just a case of military destruction. It's got to, through data processing, it's got to be mechanically destroyed. And I've heard of things in the news of situations where somebody's set up one of these processes. They've sent it off to a third party. Next thing they find out, it's ended up on some tip in some other country in the world, or it's ended up on eBay, for example, because these businesses, they didn't go through. They've sold these contracts to destroy these drives, and they never actually got through with it. They've passed that out, over to another company, who in turns maybe passed it to another company, and it just never gets done. So it's a case of, if you've got data on here, I mean, hard drives fail, which means you can't get access to them normally, but you can have the potential of still being able to recover the data. There are actually businesses out there who are actually set up to recover data because your computer can't, but they've got systems that can. So it's a case of, if you encrypt the data, though, they can't touch it unless they've got the actual key, or unless they've got the passphrase. That data cannot be encrypted. And it might be a case of, somewhere down the line, you decide to, the computer, maybe the hard drive stops working, and you don't want to go through that process of actually destroying the hard drive, or maybe the computer's broken and you take it to a third party to repair it, for example. You don't want them being able to have that potential to get access to encrypted data. So unencrypted data, I should say, that's sensitive. So I would also suggest to make sure, if you've got any sensitive data, don't bother encrypting the entire folder. It's just going to add performance hits to it. Create individual folders and encrypt what you need to encrypt. Leave the rest unencrypted. Anywho, it's enough of my rant. Once you've actually picked all these drives for your pool, pretty straightforward. We just click on the create button. So in my case, I've just picked the whole lot, and we're going for this suggested setting of RAID Z2. But you can change this. You've got lots of different options here. So I'm just going to click on create. I mean, notice that was actually even an option for level 3. That would have been 3 priority drives. But the more priority drives you're adding in there, obviously the less data capacity you've got. Anyhow, the warning, everything on these drives are going to get wiped. Are you sure you want to do it? Yeah, of course we do. It's a new computer. Why should I care? So off it goes and then creates the pool. Now, the thing to bear in mind is there's not a great deal at this stage to do, because it's a case of it's created this pool, and it's just a bunch of drives basically all bundled into a pool, but you still don't have anything to actually get access to over the network. There's still nothing there to access. You can't upload files to anything, you can't download, and that's where we get into the realms of, you know, sharing, which I'll cover in another video, because this video is more to do with installation than anything else. I want to split this all up, because it might be a case of somebody already knows about how to do the installation. They just might be unfamiliar or not quite sure about how to do certain types of sharing. So I find it easier if I split this all up into separate videos. So then, you know, if you want to get information about a specific part of TrueNAS, you'll go to that specific video. But just as a kind of like an overview, like I was saying, I mean, I wouldn't go into the process of using the actual pool itself. I mean, you could potentially share the entire pool, but what I would be more inclined to do is start setting up what's called datasets. So there's still folders to me, but TrueNAS prefers to call them datasets. So once you've got your pool created, you click on the ellipses over here, and you've got an option at the top called Add a Dataset. So we click on that, and basically just asks you what you want to call it. So I might have one called, so for example, home. The idea behind that is I've got users on my network, and I want each of them to have their own home folder so they can store information specific to them, for example. So every time we create a user, they'll have their own home folder, for example, so they can put data where they like, and it's, you know, it's private to them. Nobody else can get access to it. So yeah, I might create that as a data set, for instance. I mean, you can put comments in about it if you want. There's other sort of features, but we'll just go with the defaults there. I could add in another data set in there. I might call it, so for example, maybe this is going to be called my ISOs, for example. So it might be a case of this might be somewhere where I'm going to store ISOs for my hypervisors to be able to get access to operating systems, to be able to install when we create virtual machines, for instance. I might create another data set. I might call it, so for example, I'll call it shared, for example. So that could be a shared folder where I allow access to, you know, different people can get access to that. I mean, if you're into businesses, I mean, you might be setting up folders for the finance department, folders for the IT department, folders for HR, this sort of stuff. The whole idea is then, once you've created these individual folders, you then share them out, and you assign permission to a specific group, so only certain people can get access to them, and they've only got certain rights. So I mean, you can go right down to the wire in the sense that you can allow access to an entire group. There might be a certain individual that's not in that group, but they need access for whatever reason, or it might be a case of, you know, there might be a group that you've got, and there's a certain user in there that you just don't want them to have like write access, for example. So you can actually set this up where you know, the entire group has full control, but there's a certain individual we don't quite trust, so yeah, we'll actually deny them like write permissions. It's that flexible, I must admit, and it does seem to go right down to kind of like worst case. So even though the group might have full access, the individual user is being denied write access. So the NAS does actually take that into account, so they don't get full access. They are denied that write access. It's quite clever, that I like that, least privilege, as it were. But anyhow, once we've created our little data sets, this is where we actually get into this idea of setting up the permissions. And that's what you do, is you go to each individual data set or folder, if you will, click on the ellipses on there, and on these we've got an option for permissions. Now, if you're into like small businesses, for example, it might be a case you've only got a certain amount of disk space. You might have certain users who, well, they tend to upload quite a lot, in which case then you can get into things like user quotas, group quotas, because you have to start getting a bit realistic on terms of your storage capacity, because otherwise, if people just keep adding tons and tons of data and it starts consuming space and you're running out of space, it becomes a problem. So I do quite like that option for quotas, but in our case anyway, what I want to do is edit the actual permissions for that, because this is where we tend to set who can get access to what. Typically with the shares, you share things out and it's just pretty much a free-for-all. You're not too fussed about who gets access to the share because it gets a bit too complicated. You can have rights and rules on the actual sharing of the folders, who gets access to it through a share. And then you've got another set of rules as to who can actually do anything at a file level. So when you've got two different sets of permissions, it can get a bit cumbersome to control both. So typically what you do is you set the permissions here at the file level, and that's what we've done. We've gone into edit the datasets permissions. So these are file permissions. Now by default, the root is the user who's got access, and wheel is the group that's got access. But you can change those, and you can start changing whether users have got read permission, whether the groups have got write permission, whether everybody else, in other words other, has got execute permission. You can change all these. But there is another way of doing it, and that's to use what's called this ACL manager if you want instead. So with that, we can actually start applying what's called an ACL, which I quite like, I must admit. So by default, it goes with what's called here a preset option. So typically you'd go for, say, if you've got a home folder, you do actually have to select that option. I'll go over that in another video, but typically you'd probably go for this where it's a restricted option. So we'll go with restricted. And then basically what it says is whoever's the owner has got full control. Whoever's a member of the group has got modify access. So it really depends on the user, whether you're doing this with individual users, individual groups, or so on. Because typically it might be a case of whoever creates the file needs full access. Other members, they might need just the ability to modify it. But it's a case of once you've set up your permissions, off you go. But you've got to remember about who the group is and who the user is. That's something to bear in mind. So it is all pretty easy, I must admit. Just a case of setting up, you set up your pool to begin with based on the number of drives. You can keep changing to that if you want to. Then you start setting up your data sets, and then we're into the realms of actually sharing things out. So there's quite a few different ways to share, for example. So for instance, up here we've got options for Apple sharing, block shares, more commonly known as iSCSI, Unix shares, which is more commonly known as NFS. We've even got WebDAV shares over there, I've noticed, but more common one I'd say is probably going to be SMB. If you're running Windows computers, you'll be more likely to use those. And these just take you into the list of those specific shares. Now we don't have any set up, but I'll go through that process in another video. Now when it comes to actual services, what I do like is that most of these are all disabled out of the box. So for example, it's not actually set up as a Samba share, for example. It's not actually doing anything. So if you're not actually using SMB as a sharing option, the service itself's turned off. So I do quite like that. It does run the smart service, which is used for like checking the hard drives and what have you. But all these other services that it's capable of, they're all disabled by default, which I really, really like. The interesting thing is once you start sharing something, whether it's NFS or SMB, for example, it automatically turns the service off. So yeah, that's quite useful. All sorts of plugins if you want. I'm just going to cancel that because that's for setting up the jails. But you don't necessarily just have to use this as an actual NAS. I mean, if you want, you can actually install these extra plugins. So these are the ones that come with the operating system made by the manufacturer. So you've got these ones. So a common one, for example, is Plex Media. You've also got community ones that it knows about as well. Quite a lot in here, I must admit. I mean, if you're into like smart homes, for example, you'll probably recognize Home Assistant, for example. Further along, it's got the Mosquito MQTT option as well. We've got Node-RED, for example, OpenVPN servers and options. There's quite a lot of community plugins that you can install as well. So it really depends what you want to use the NAS for. Maybe you just want to use it as a NAS, which is what I'm going to be doing, or maybe you want to use it as a kind of like a centralized computer. And if you're going to go down that sort of path, I mean, you've got options for like jails as well. You've got options for creating virtual machines. There's all sorts of things you can do. So there's a few different options you've got in here. I mean, I notice in here you've also got an option to get access to the shell as well. So that automatically is logging in as root. We've logged in as root. So I mean, if I have a look at, say, on the mount folder in that specific pool, so you can see we've actually got some folders or data sets, if you will. So if I do -AL as an option, you can see that those folders that we've created, they've all been assigned to the root user and the wheel group. So I mean, you can change them through the shell if you want. You don't necessarily have to do it through the web GUI, but typically for most people you'd probably be doing it through there anyway. I mean, one of the things you can do as well, I mean, if you're getting really into sort of user control and what have you, you've got all sorts of options in here as well. Actually, things like Active Directory, LDAP, NIS, Kerberos, and all sorts. But I think for most people, probably you'd especially like home users, it's more a case of making some tweaks for the system just to fine-tune things a bit. You'll be into the storage for creating your pool to begin with, setting up all the drives, and then creating your data sets, and then we'll be into sharing to set up the shares. You might go down the realms of the plugins, the jails, and the virtual machines, if you will, but that's pretty much it, other than setting up the user accounts and the groups. There's a few other options up here. It's got, tells you like the list of tasks, list of alerts. The settings up here is more to do with things being able to change your password. Preferences is more to do with, you know, setting the theme, for example. Up here you've got the option to log out, turn the computer off, restart it. One thing I'll point out, which I did find a bit interesting, is what happens if you actually decide you don't want that pool. Let's say you've built this pool and you've suddenly decided, actually I don't want that anymore, I want to rethink this is not how I want to do it. Bear in mind, I mean, we're actually going to end up deleting the data as well, so yeah, this is more of a case of probably you're either doing it when you're starting, or it might be a case of, you know, you've taken that data off altogether and you've got it somewhere safe. Because bear in mind, even though I've got, in theory, I've got a computer that's got all these hard drives, and we've got all this extra redundancy where our data is spread across several data drives, we've got 2 parity drives. This doesn't guarantee you will not lose your data. You've got to back this up. Either back it up to an external drive, and also maybe to a cloud, or back it up to another NAS and then up to the cloud, or back it up to an internal computer and then back it up over a VPN to another site or something. You've always got to have internal backups in case this thing goes completely pear-shaped, so you can recover your data locally. But also you need off-site storage as well. It really depends on how important that data is. I mean, if this is data that you've had for a long time and it's very personal to you, we're talking things like photos, for example, it's a case of what's the cost really to you if you lose that data. It doesn't necessarily have an actual value as such, but what would happen if you actually did lose all of your photos that you've taken from all the different places you've been to on holiday, or for example, this is data that it might be, as I say, not necessarily worth anything as such, but it could actually have a lot of personal value to you. So do think about the fact that you'll want to back this up locally to something else. Plug a USB drive in, for example, that's got the similar capacity. Back it up to the cloud, for example. Find some way to make sure that you've got all of that means to get your data back. But I kind of like went off topic there, because the idea is, what do you want to do when you actually do want to delete this? So you want to rebuild it. Well, it's interesting because if you go over to the options here, that's where you go to. You click on the wheel and you select the option to export/disconnect, because at the moment you can see that the pool's online. But if we want to completely rebuild this thing, we click on that option and say, well, we want to disconnect it effectively. And then it comes back and says, okay, well, are you sure about this? We're getting plenty of warning about it for those very reasons I was telling you about. But in our case, I just want to start from scratch. I've had a change of plan. So I've got a choice here, so I can completely destroy the data on this. I want to start from scratch. So, are you sure? Yes. So it's making sure by asking you to type the name of the pool in, and I need to also confirm I want to do this. So what it's going to do is it's going to destroy all of the data. It's then going to delete the configuration, and that's our confirmation. So I'll click on that. It does take a bit of a while, I must admit, to do it, but it means that I've wiped this entire pool. Those drives will then be free for me to reconfigure and do something else with. So like I say, like maybe you're just getting started and it's a case of I made a mistake there, I don't need that many drives, or actually I've just been able to get an extra drive, I want to put that into that part of the pool. So there you go, it's all gone. I've got a warning up there, or an alert, but what it means is I can go back and start from scratch, and I can do this in a different way. But I brought that up just because the fact it's not so obvious how to do it. I had to go out and find out, how do I actually destroy that pool? How do I actually begin from scratch? So that's definitely useful to know. So, like I say, what I'm going to do is I'm going to cover different parts that I'm interested in particular, and I'll do those in separate videos. So I do definitely hope you found this particular installation process, interesting, if not useful. Very, very simple to do. There's hardly any questions that it asks you, so it's pretty much just works out of the box. But I just wanted to point out some of the other things I think are important, things like being a bit more security conscious in terms of how you actually set these up and configure them, just to be on that extra safe side, because at the end of the day you just never know who's on your network.